Welcome back. This is our last example um, in this series of videos. Um, so again, we want to solve this inequality without graphing the function here. And so we have this rational function here less than 0. We want to find out the values of x for which this rational function is strictly less than is negative basically. So the first thing we need to do is figure out the partition numbers for this function. Well, the partition numbers would be the numbers where the function is either 0 or undefined. Now clearly the function is this function would be 0 wherever the numerator is 0, and the numerator is 0 when x is negative 5 or when x is 4. And the function is undefined when x is negative 1 clearly. So those are the partition numbers of 4, negative 5, negative 1, and 4. Now these three numbers, we're going to plot them on the number line, and so they divide the number line into 4 subintervals. Now in each of these subintervals, f is continuous and f has no zeros. So in each of these subintervals, f doesn't change its sign. So f has a constant sign on each of these subintervals. So therefore, to figure out the sign of f in each interval here, we just have to find the sign of f at a single point in each interval. So let's figure out what is on the left side of negative 5. I can pick the number negative 6, and f of negative 6 would be negative 6 plus 5 would be negative 1. Negative 6, negative 4 would be negative 10. Negative 6 plus 1 would be negative 5 squared. So altogether I see that this is positive, and so then f would be positive throughout the interval to the left side of negative 5. Now let's pick the number negative 4 between negative 5 and negative 1. If we plug that in, negative 4 here is going to give me 1, and negative 4 here is going to give me negative 8. Negative 4 here would give me negative 3 squared. We see that this time f of negative 4 is negative. So f is negative throughout the interval from negative 5 and negative 1. Between negative 1 and 4, we can pick the number 0, and f of 0 would be 5, negative 4, and 1 squared here, which we see that is negative. So we can then say that f is negative in between negative 1 and 4. Lastly, in the interval after 4, we can pick the number 5, and f of 5 would be 10. 5 here would be 1. 5 here would be 6 squared. And then we see that f is positive here. So we just found this then. We see that f is, recall that we want to know where f is negative. So we see that f is negative in between negative 5 and negative 1 and negative 1 and 4. So we see that the function is negative when f is when x is between negative 5 and negative 1, and when x is between negative 1 and 4. So the answer is that the solution to this inequality is the set of all x such that x is between negative 5 and negative 1, or x is between negative 1 and 4. In other words, if x is in the interval from negative 5 to negative 1 union negative 1 to 4. Notice that we should not write the answer to be the interval from negative 5 to 4 because negative 1 is not included in the solution. Okay, so that's the end of my slides, and so we will stop the video here. and I hope to see you in the next series of videos.